Okay, so welcome back. This is part 3 in our series where we're showing you how to develop this awesome C# Windows Forms application. Now, what does this application do? Well, as you can see, it is providing us with real-time updates that show us the location and heading, and also here we've got the call sign for aircraft within a certain radius of a location. And what you can do is you can request for any location in the world within a specified radius. You can go to the web server, and we're using a web server called airplanes.live, which gives you free data. And every second we're going out to airplanes.live and saying, hey, at this particular location, give me all of the detected aircraft within a radius of, in our case, 30 miles from that location. And what it does is it gives us a list of tons of information about all of the aircraft, the location, the heading, the altitude, the call sign, bunch of other data about the aircraft. And what we're doing is we're taking, in this case, we're taking the location and latitude and longitude, the heading, the call sign, and we are placing images representing each of those aircraft on a satellite image in the background, and we're updating it, as you can see, every second or so. You can see these aircraft move their locations. So what we did in the previous video is we showed you how to very simply request data, just with a few lines of code, send a request to airplanes.live and tell it, hey, here's a center location, give me all of the aircraft within a radius of, for example, 30 miles, and how we can grab the data that it returns to us and automatically map each one of those, all of the data representing each aircraft, into a list of class objects we called flights. So we set up a flight class, and it automatically maps the incoming data for each flight to its own flight class object. So we have a list of all these flights, and we can go through and just place them on this image. So what we're going to do in this video is, now that we've got the information about the latitude, longitude, and heading, and other information about each flight, how are we going to map that to this satellite image? And, where are we going to get the satellite image? We've got data coming in on latitude and longitude. That doesn't help us put it on top of the satellite image. So somehow we're going to have to figure out what is the relative latitude and longitudes of the aircraft relative to what we're seeing in this satellite image. So in this video, we're going to show you how to get the satellite image and how to get the data we need so that ultimately we can map each flight to a location relative in this satellite image. So first thing we're going to do is we're going to go to Google Earth, and we're going to see how we can download this satellite image and the associated information. So here we are in a free application called Google Earth. I'll assume you know how to download and install that if you don't already have it installed. It's absolutely a wonderful application, and again, it's free. And what we're going to do is we're going to use this to help us to implement our flight tracker application in C#. So here we are looking about 3,000 miles above the United States. Let's pick a random location in the United States around which we want to monitor air traffic. So here we have Texas. Let's zoom in on Texas. And we've got Houston, we've got Dallas, Fort Worth, San Antonio. And you can see down here we've got a city called Waco, W-A-C-O. So let's randomly choose Waco, Texas as the center of our air traffic monitoring. So what we're going to have to do is we're going to have to get two things out of Google Earth. One, as we said, is basically this image, a satellite image that we're going to use as a background, but also we need to have what are called place marks, which give us the latitude and longitude of any location in our image. And you can see as we move around down in the bottom right, we've got a real-time update of the latitude and longitude of any point here. So we're going to have to figure out how we can get the latitude and longitude coordinates of the corners of whatever image we choose. So these upper left, upper right, lower left, lower right. we're also going to want to get the latitude and longitude of the center of this image. So we can tell our web server, hey, we want this latitude and longitude in the center of Waco, and we want all of the air traffic that is detected within, in our case, say, 30-mile radius. So we'll start out with Waco, Texas. Now, the first thing we want to do is we want to go up here to the Places and go to My Places and right-click and add a folder. And that's really important. It's going to hold all of the data on all of the place marks, the latitude and longitude place marks, the 5 place marks, and it's going to put all those in that folder, and it's going to allow us to take all of those place marks and convert them into a file that has all of the latitude and longitude data. So we're going to take this folder, we're going to call it Waco, hit OK, and now up here you can see we've got a Waco folder, and in that we're going to put our place marks. So the next thing we want to do is we want to make sure we're looking at the center of this image. Looks like it's about center. We're going to go up here, and on this push pin up here, this yellow icon, it says Add Place Mark. We're going to click on that, and you can see we're pretty close. We can move this up a little bit, do it again, and here we have a place mark right in the center of Waco. So it's presently untitled, it's flashing, so what we're going to do is we are going to give it a name. Before we move it, we're going to call it CENTER. So now we have a place mark that defines the center of our view. And we can right click on it, go back to properties, and you can see it's got the latitude, 31.53, longitude, -97. All right, so we have now locked in the latitude and longitude of the center of our image. So the next thing we have to do is add the 5 corner markers. So we're going to go back up to place mark, hit add place mark, and very important, before you do any naming, we want to take the place mark and move it first. And we're going to move this up into the upper left-hand corner, and then we're going to name it as upper left. Now we want to do the same for the other 3. And you can see that we have our Waco folder, and both of those were automatically added to that folder. So I'm going to do another one, add place mark. Before I name it, I'm going to move it to the upper right corner. We're going to call it upper right, and we'll do it again for the lower left. First we have to move it, call it lower left, and then the last one we will add it and then move it down to the lower right. And now we have our 5 place marks defining the latitude and longitude of all of these important locations, and again they're in this Waco folder. So 2 things we have to do. We have to save this image so that it is centered, and we also have to save all of these place marks so that we can access them later. So the first thing we'll do is we will save this image, and to do that we can go up here to these icons, and this icon here says Save Image. So we're going to click on that, and it'll take a second, and it will come up with this menu list, and it's got map options, resolution, and save image. So first thing we're going to do is we're going to choose the map options. I'm going to turn off this title and the legend, so those 2 are gone. So now we just have a clean image. Then I'm going to set the resolution, and this is important. What we want to do is set the same resolution for all images. If we have multiple images in our application, we want them all to be 1920 by 1080 or whatever resolution you want. We want them to be consistent so they'll fit into our picture box and so on. So I'm going to choose 1920 by 1080, and then we're going to go and save the image. So we'll click Save Image, and we can put it into whatever folder we want, and it's going to be a JPEG, and we're going to call it Waco, and it's going to add a JPEG to it, and hit OK. And now we have just saved that image into the folder. Then what we're going to do is we want to go to the Waco folder, right click, and select Save Place As. And what it will do is it will take all of those place marks and save them into a single file with all of the data associated with them that we can parse. So it defaults to save as type KMZ, and that is a zipped file. We don't want that. We want to select this and go to KML. And you can see I've got some other KMLs saved, but I'm going to save it as waco.kml in the same folder where we have our image. So I'm going to hit save, and now we are all set. We've got all we need from Google Earth. And we can go into that folder and we can see I've got some others, but I've got waco.jpg and waco.kml. This KML is really important because it's going to allow us to parse it and get back all of that data on the latitude and longitudes. And what you can do is you can edit that. It's basically just a text file, and I'm going to edit with Notepad++. And here is the file that we saved. And it's got an XML version, it's got some references that we're going to need, and it's got the name of the folder, and it's got for each of the place marks, you can see the folder name is Waco, and each place mark, here's the center place mark, here's the latitude and longitude, the upper left, latitude and longitude, upper right, and so on. So all we're going to have to do is figure out how to parse this KML file and extract all of the data associated with this image. So here we are in our C# application we're going to use to do the tracking of these aircraft. And here is a method we're going to use to extract all of the latitude and longitudes from those 5 place marks that we put into this KML file. And then we've got a folder called Waco. Remember, we saved that, Waco. And it's got 5 place marks. They're marked as a place mark and then a / place mark to end the information with that place mark. And it's got longitude and latitude and some other information. And then that's the center place mark. There's an upper left, upper right, lower left, and lower right. So all this code's going to do is extract those values, latitude and longitude, and the names of the place marks so that we can use them later. So public void extract place marks, and we just have to feed it the file path, the path to that KML file wherever it is. And we've got a try-catch block here, which you may or may not need. What we're going to do is we're going to use the X document, the system.xml.link X document. And you can see we're using system.xml.link. And since this is an XML document using geographical stuff, we've got our X document, we're going to call it KML document, and that's basically you're loading from that file path, you're loading that KML file, calling it KML document. But then, since it's geographical stuff, we're going to have an X namespace, we're going to call it KML namespace, and we're going to refer to this http www.opengis.net KML 2.2. And if you look in our KML file that we generated, you can see it also has that reference on the top, KML OpenGIS.net KML 2.2 with some other references. So that defines the namespace. Now, honestly, this XML stuff, I'm not a big user of XML, so I had to go to ChatGPT to ask it how to extract latitude and longitude from this KML file, and it gave me this code. So if you have any problems, I encourage you to look at that. So we've got a KML doc, KML namespace. I've commented some of this stuff out. And what we're going to do is we're going to look for the descendants referred to as place marks in that document. So KML document.descendants, and we're taking the KML namespace plus the place mark that we just saw, and that will give us an IEnumerable of place marks. And then we can step through each place mark and extract the value associated with that place mark. So for each var place mark in that IEnumerable, we're going to get the name, which is placemark.element, where the element is a name. What is that value associated with that name? So here is the center, the name, and we want the value associated with that. And then the coordinates is placemark.element, KML namespace plus point.element, KML namespace plus coordinates.value. So it's going to get the name and the coordinates, the latitude and longitude. If that is not equal null, we're going to say var coordinates is coordinates.split using a comma, because when it gets down here, here is the coordinates it's grabbing, minus 97 comma 31 in this example. So it's basically splitting those, and if the coordinates length is greater than or equal to 2, all we have to do is convert to double coordinate 0 and coordinates 1, and that is the longitude and the latitude. And what I'm doing is I am taking those values, the name of the place mark, which is center, upper left, lower left, and so on, and adding the latitude and longitude and making those as a geolocations object, which we'll talk about later. But I'm just grabbing those three values, latitude, longitude, and name, that we can put into our code that we can access later. And then the other end of this is a catch, which you can use if you want. But basically that is the code you're going to need to extract each place mark and put the latitude and longitude associated with those place marks in some sort of data structure, as we'll talk about later. So in the next video, we're going to discuss what is likely the most challenging part of this whole application. We've got the latitude and longitude and heading of each aircraft. We've got a map and relative latitude and longitudes of the satellite image. But now we have to figure out how we are going to draw all of these images of aircraft on top of this map. And it turns out it can be kind of challenging. And it also turns out that what might seem the most intuitively obvious way to approach this can end up being the most time-consuming and slowest responding. And we're going to show how there's a much faster way to do it that you may not have considered. And we're going to show you how to draw all of these aircraft. You know, you might have 50, you might have 100 aircraft, depending on the range you select and how busy it is. So how are you going to draw all of these images with the right location and heading and make it so this application doesn't slow down so much that you can't even use it? So I encourage you to watch the next video and see how you can actually implement this. That's it for this one. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.